Now that we have our graph made for position and time, we need to think about velocity. The error bars are on here. That looks pretty good. So let's go over here and we will calculate what our velocity is. And our units here are going to be centimeters per second because our distance is in centimeters and our time's in seconds. And we can't have a velocity for the first point because we need to compare two distances and with times because we need to change. So we'll start here. And my velocity is going to be equal to my change in distance, so I need to subtract the current distance from the previous distance and then divide by the change in time. Follow the same pattern. And that gives me my velocity. Again, the shortcut, Control down brings you to the bottom of a column, Control Shift up brings you to the top and highlights, and Control D fills them all the way down. So you can see my velocities are increasing as I go down. It looks pretty good. Some people like to put a 0 here because they say, hey, it started from 0, I know that in the video. It's up to you whether you want to put that in there. If you do enter it in there, I suggest that you maybe highlight a different color just to remind yourself that that's not a formula, that's the end number you put in. And then we need to graph that. One way to graph it is to use the graph that we already had because we did the axes and the labels and the error bars. And so you can right click on it and then you can go to copy, which is Control C. And then I can just paste it. Maybe I'll just paste it right here below it. So now we have the same graph. And now I'm going to change this graph. Instead of starting from scratch, I'll make this the velocity graph, make that centimeters per second. And then I need to go in and change my data. So here we had time was A, the Y values were X was B, and now we want to change that to having D. We want the velocity. So an easy way to do that here is just to click in and change the letters from B to D. And now I have my velocity graph. One problem here though is this is the velocity graph but with the X error bars. So now I need to change these. So before I can change them, let's calculate what the velocity error would be. So one way to do that is to calculate the minimum velocity and calculate the maximum velocity. And then from those two, and looking at the difference between the max and min and our actual velocity, we can get a velocity uncertainty or a velocity error. I like calling it uncertainty better. It's a little bit easier to not mix up. All right, so our minimum velocity here, we have to think. I'm going to have the same formula here. So I can copy the formula and then I can paste it into this cell. And to get the minimum velocity, I want to have the minimum distance here, which means I want to make B4 as small as possible. So I'm going to subtract my error. And I want to make B3 as big as possible, so I'm going to add my error. To do that, I'm going to put parentheses around them first to avoid getting confused. And so here's B4, and I want to make that as small as possible. So I'm going to subtract the error that matches B4. I'm going to do the same thing to B3, except B3 I want to make as big as possible. So I'm going to add my error that lines up with B3. So now I got the smallest ending interval and the biggest beginning interval, and that will give me my smallest difference in position, which will give me my minimum time. And it should be lower than this one. It is. Now this negative value sometimes gets confusing. Let's pull ahead and look. So 11 is less than 17, 18 is less than 24, and this negative value tells us that our error is large enough that our car could actually going backwards with the error we have. We can test that real quick. What if we had 0.01 here? And you can see how the error changes. So we'll go back and look at how that changes our graph in a second, but these formulas look good. One way to do the maximum is I'm going to copy this formula because we already wrote it in there. It seems to be working. And I'm going to paste it in here, except now I have to do the opposite. I want the biggest interval, biggest position at the beginning and the smallest position here, and that should give us our maximum velocity. And you can see that it looks good. And so what I did here is I held shift and pressed down to highlight as I go, and then just Control D was filling it down. Alright, so now this is a maximum, it's bigger than the velocity. Here's a minimum, it's smaller than our velocity. So that looks like it works. Now to find the uncertainty, I need to look at how far away the minimum and the maximum are from my actual velocity. And I want to take the biggest value. So the max command takes the biggest values of a bunch of numbers that you give it, and I'm going to give it two numbers. The first number is going to be the difference between my actual velocity and the minimum, so I'm going to subtract those two. The second number I'm going to give it is the difference between the maximum velocity and my actual velocity. and that gives I'm 6 away. So 11 is 6 more than 5 about. Negative 0.6 is about 6 less, so it looks like this is working too. And if we fill down and check it, they're all about 6. That looks pretty good. So I'm going to fill both those formulas down. So here I can go to the bottom and I can highlight 3 cells over and then go Control Shift up, and I can fill all those formulas down at once. So now we have velocity, min, and the uncertainty. Now that we have the uncertainty, I can go over here and change my velocity uncertainties to match. So we can try right click on these to try grab the error bar. Sometimes zooming in will make it so we can try grab an error bar, but it looks like these are going to be hard to grab because they're so small compared to our velocity. If that's the case and you can't grab them, sometimes it's worth it just to go in here. Let's move this over a little bit. So go into the plus, hit error bars, and from here you can go to more options and get the menu for specify value. And at this point here I can just overwrite them. I could change the C's to G's because that's where my values are. So maybe that'll be an easy way. Or sometimes if it's just getting hard to find it, I can just delete this out and I can just choose my errors and drop them down. One shortcut here is I can click this reference and Control C to copy it, and then in here I can just Control V and paste over it instead of highlighting, so that can be a useful tool sometimes too. And then G4 to G28, let's remember that, that looks good. And when I look at my graph here now, let's zoom out, you can see the error bars are pretty big. One problem here though is I don't have error bars in this point, and let's think about why that is. So if I go back to format my data series, if I go back to select data, and look, I'm going from 3 to 30, and before I was going from 4 to 30 on my errors. So do we want to graph this point, this 3, and right here we have a blank, even though we put a 0 there. So for this graph here, I'm just going to start my graph at 4 to match those error bars and ignore this first point. So when I do that, let me look at the graph here. Now I'll have error bars for all the points that match up, and I don't have my 0 point. If you wanted to include that, you could put 0 there and just say, hey, it's 0 uncertainty because I know it wasn't moving. That would be another way you could do it. You could put a 0 in here. Again, I would like highlight that cell to remind myself that I put that in there. And now if you did that here, you could go back and change all your data references back to the 3 to include that first point. And then you also have to change your error bars under here specify value. We need to make that a 3 2 to line up. So we always want to make sure everything's lining up. If you click in here and you can't get over because you don't want to use the cursor, deleting the delete key actually moves the character after the cursor mark. Sometimes that's useful instead of having to do erase and click around. So now that I put those in here, I can see here that I have a 0. Uh-oh, no error bar though. Well, I guess there's an error bar, it's just 0. But let's double check and make sure that those references are still, that I put those in right. So 3 to 28, 3 to 28. Uh-oh, but we're going to, yeah, 28. All right, that looks good. All right, so now we have a graph of velocity with uncertainty. We can test this out by changing what our uncertainties are. So if we look here, maybe one's kind of big. Maybe I could go back to my video and check it and change those to 0.5, and then we can see how the error bars shrink. Now, we want to know if the velocity is increasing or the acceleration is increasing or decreasing. So we'll save that one for the next video.